back to my YouTube channel. Today I want to speak about gating. Gating is a concept. Sorry, I want to speak about the rifters manifest. Rifters, rifter or rift more specifically. Rift is a compiler to chain. It's written in the MVP or the minimum viable properties. It was written in C. But I'm trying to migrate it to Rust for the R syntax. So what is Rift? Rift stands for Rift is a flexible translator. Rift is a flexible translator. It's a direct competitor to something called Yak. Yak is a builder for building programming languages. But you know the thing about Yak is you have to spend 6 months learning it and 6 months building a project. It takes a year to build a prototype for your projects. It's cumbersome. It's not worth it. It uses C. It's written in C. But we're trying to migrate Rust to C. But C to Rust. But the MVP is developed in C. What does actually Rift do? Rift changes the whole thing about programming, how we build programming languages, from the tokenizer to the parser to the AST, the three main layers. It would take if someone has used these three main layers, that's why I consider something that can change, evolve, like Python, or stabilize, something that can be useful. Rift is the first. It's a commercial system to build programming languages. It's based on configuration. So you have something called a golf.rift.rc, which stands for read only configuration. .n when n is stage bound for each stage you do, based on the input, stage bound execution, and the tokenizer thing. So I'm gonna draw it now for you, but give me 2 seconds. Rift stands for Rift is a flexible translator. The R syntax is what is used to determine how Rift works. Okay, so let me just draw the documents here. I haven't written it down, but I'll draw it here on my screen there. It's there actually, but it's giving me a notion. But it's here, but it's gonna work here. Okay. Let me show you a model of how this works. Okay. 1 second. So this is my screen here. So this is my screen. So this is how it works. 1 second. So right now, looking at me, this is how it works. So you go to something called the R syntax. Say you want to C, and you then so the first one is the stage bound execution pipeline. So you go to how this works here. You go to stage and the thing. So you got the new type. New type is first of all. So you got the model of token type or memory, token memory. I'm just undo this right now. Token type, token memory, token memory. That's the memory, and token of value. And token of value. This all means so this is how we have compile time safety in the Rift. But this is how we are. So we separate the token type from the token variable data. So every time something has a token memory, allocate that kind of memory to the system. These are implemented as structs in Rift, such as the fly there, as structs. So we got each individual struct accumulated token value. When something has token memory or token type, or token value, it's really considered Rift compliant. It's gonna be queue bound. We can memory is fluid. So remember memory is fluid. I'm trying to. I should be like a. So it's like water. Memory like water is fluid. You can change. When you allocate more memory to a program, that's why memory is fluid. It's fluid and dynamic. Dynamic meaning it's not like it can grow or shrink. So it can grow or shrink. Yep. And we got token value. You got token type. Token type. Wait, what was the? I'm gonna reach that. I can't reach this. But that's I can't reach. I don't know how to reach that. Yep. So this is a token type. So that's what it is. This is a Rift token. So we have like a token. This is called a token triplet in Rift. It's very important to remember this. That's a token triplet. So it goes 1, 2, 3. What a token type. So I'll show you how this works. The token type is just the type of the whether it's an int, a string, etc. But there's three main types. You got to understand the stuff, the statement and inspiration layers with intent layers, which is just what do you mean by the WYSIWYG conversion? WYSIWYG conversion. I'll come back to that later. But that's what I'm saying. So we got three layers to it. We got yeah, I got three layers. So we got the token type, and this is all implemented in C. Yep. So this is different. C Rust. So when you have this, you have compile time safety. This is how compile teams work. Just separating these two tokens. The way to go is compile time safety is a key principle. So principle A. Don't worry about this. Yep. One second. Let me just get reset here. Yep. Token type. Structure. So everything is implemented as struct. Yep. So this is the riff triplet. This was called the riff triplet. Let me just draw three alleles. Like, what do I draw with? Orange, purple, like black, blue. Yep, I can't see blue. So this is called a token triplet. This is a triplet. The triplet just makes it a riff token, a compile time safe riff token. Because how this, because it separates its original component. You don't have to. So when something is compiled with Rift.exe or Yak, it's not compiled time safe. So this is what I'm trying to do. So we do compile time safety. We try to let me get some colors. A different one. So Rift. This is black. This is 3. No, this is like highlighted. I don't want a highlighter. I want a pen. I want a pen that's not highlighting. So this is like I'll change. This is a highlighter. So this is not a highlighter. So I'll change this to black. Yep. Yeah. So this is Rift. Rift.exe is compile time safe program, or this is called the Rift client. Rift client. And this is what you use to build. I'll come back to that later. So what you do with the Rift client, you run your program through a configuration system. But Rift, so this advantage here with compile time safe. Compile time safe. That means because you use the security process, everything you stand will be compile time safe. React is not. Yak is not. Yet another compiler or Yak. Yet another compiler. It's not compile time safe. It's not. So this is sorry. It's like a. This doesn't have that feature, but this is have that feature. Compile time safe. It's not compile time safe. Not compile time safe. That means when you run the program, it doesn't check for the compilation issues. It doesn't check for what is compile time issues. That's how Rift tokens are. So these are Rift token, Rift client tokens, or Rift tokens. These are tokens for Rift. .exe. And that's the first thing I want to say. So Rift is a flexible translator, but how does this all work under the hood? I'll show you how this works under the hood. And I'll show you manual viable product or just a proof of concept later. So how does this work? How it works? How it works is this: we got something called the R syntax. So the R syntax is the okay, let me not. Yes, the first step is showing how the stages work. So the stages work by this. So you work. Everything works in stages. Hence the convolution system. So I'm gonna explain the convolution system now. So we got say being a tokenizer for your program, your custom tokenizer. Let's say you want to implement something like this. So you want to implement something that matches. Oh no, this is not right. Yep. No, this is not. This is too big. I'm a rifter. The term for rifting is rifter. Anyone that uses the philosophy or uses rift. We got philosophy as well. So I'm building a community around this build tools. It's a what rift is it's a compiler tool for building. It's a compiler tool for building programming languages or what's known as domain specific languages called DSLs. If you want to, it's meant to build my programming language Gossy Lang. Gussie is a gossiping programming language. It's a polyglot programming language. To build. It allows you to talk to any programming language, whether interpreted or compiled in a useful system. It's a programming language itself. It's called gossip programming language. The gossiping, related to networking, or the concept of networking, or talking to different dependencies. You got gossiping. The gossiping command, gossi.exe.pin, pins the network to a thread, or process of the computer. That's what the pinning command does. Or the unpin command does. Yes, so don't unpin that still. Only pin things that are QA bound. You're sure it works. Gossipin dot it's a you can install that. It's a polyglot system that took to any programming languages. So we're binding from drivers. Okay, so we got this. How does this work? How does Rift work? So Rift goal is to build Gossip Lang, which is my programming language. So the first thing you're gonna understand is the system. The first thing you're gonna understand is how it works. So this so you got let me put it here. You got inputs. You got the input system. Oh no, it's not really understanding me. You got so we got this input system. You got this input system. You got inputs. This is stage bound. Inputs. Input something stage. Input stage outputs. That's the input stage output. So we got the inputs are really input based. So you got input stage or phase, input stage, stage, or phase. Input stage phase. You got the input stream. So the input stage phase output is how it works. So you got the inputs, which are your lexemes here. These are stages. Stages. A phase just means one stage. A phase of a stage. Just a phase. This is one phase. This is a tokenizer. I'll put it in a different color. Tokenizer. Let me just put it in like a bread. No, I don't like bread. Okay, let me just put it in a different color. Let me just put the yeah. So from now on, I'll use like a different color. So bread, I'll do. So got the lexemes. Oh no. Okay, so good structure there. So we got the lexeme, which is currently scans tokens, and we got the lexeme. We got the tokenizer, which is the stage of the tokenizer. The stage go downwards, and the phases go. The stage of the tokenizer. This is a stage bound, and this is a tokenizer. This is bound like a tokenizer. This is a phase bound. Well, this is like a stage bound. It's another stage. So this is another stage. So the tokenizer is a stage. Lexeme tokenizer, and then output is this kind of token type. Memory and value. Token and value, or just nil. Nil means no type, no memory, or no value, or no type or no memory. But to the value. No value means no value. No value. It can mean no value, depending on the context. What you want it to mean. Yep. And that's what I'm saying. You got token type, token memory, token value. And that's what I'm saying. So the token memory, token type, and token value are really essential to understand how this works. So the phase you go here, and this is stage 1 of the phase. So this becomes. Oh, sorry. This becomes. There's a ruler. I don't think I can rotate it. Yep, can I rotate this ruler? I can't rotate it. I don't think I can. I'll use my cursor. Sorry. I don't. Okay. So can I? So you see this ruler. Why can't anybody do that job? Like, See, I mean, this is a bad ruler, but it's gonna be bad on me when I really see it. But this is like a link on the computer anyway. So you see this? Yes. So this is like a Lexim tokenizer and token memory, token type, token value. You know, it's what it is. It's what it is. So we got this stage. So this is like this stage is stage one. Because you know we got the core layer stage one. So we got stage one being for your parser two. So this will be if this is one, this will be 100 because this is this part. This is stage one. And this is called stage 111 and 110. Sorry, and this is now 111. And this is tokenizer stage only. So when you're doing Rift configuration, this is the Rift or gov dot Rift the Rift dot 111 for this stage dot in dot XML for the input manifest or just dot XML. You know, this reads the XML files to build the target exe file that can parse the C tokenizer. And we got phase two. Phase two is parser. You got so you take this input and put it here. So you got the tokenizer already. Now you put out the include diversity to build a parser. And this takes the token type, whatever you built, whatever token you control, Rift tokens, and makes yep. And this like yep. So this they choose a parser. So this token type. So this taking the token type's memory. So this comes here. So this takes continue from this stage and so forth and so on. So how this works is now. So you now go from this page. So I'm restricting how Rift works. So I'm gonna go to Rift 6. This is Rift 1 only. Rift 0 is just the core library or C, the stability, the artifact. But you know, Rift 1 is Rift 2. So you go to 111. So you go to the types, tokenizer, etc. And you got 211, 200. So you can get error codes from everything like this. 200, you know, you can get an error code or telemetry or whatever you do. And you go 200, you go 211. 210. This is the parser stage, you know. So this is the parser. This is a translation to lexicon. This is lexical analysis stage. This is a parser stage. This is a semantic analysis. So parser. This is got 211, and this is a parser stage. This is like the done AST. So you get an AST, which is a representation of that parser. Yeah. So that's 211 complete. Now I'm going to go to Rift 3. Rift 3 is this. So Rift 3 works like this. You work. So this one becomes AST. You see this Rift 3? It comes 211. 211 becomes So you now take the AST. This AST layer does 311. I mean 300. Sorry. This is 300. You know, I'm just. I don't know what I'm thinking no more. I'm even tired. 300. Stop getting my start. It's gonna fucking. 1 second. It's distracting. The bag was very disgusting to me. Yep. Explit. Camera settings like. So this is the. Yep. So this is the 311 there. 300. Delete this here. And this takes the AST. So if you get 3, you know how to do it. But I'll see how the convolution. I'll show you how the thing works later. AST is 300, 211. 211. You got 300, 310, and 311. This is AST. This is a bytecode layer. Now, the bytecode layer is very important. It's to build, like, you know, if you're building an extension, you gotta understand how that system works. So you got the bytecode layer. I mean, yes, the EST layer, now the bytecode layer. The bytecode layer is really about bytecode. You know, things these are called opcodes, operation codes. Things like move is a location on operand. Move AWX, you know, assembly artifacts does assembly here. Assembly is what is a binary, what I'm referring to as a bytecode. But you know, this one is separated into opcode and operand. Operand, meaning like plus, minus, things are operand. So these opcodes are operands, and operand and meaning operand just means plus, minus, times things they could do, or more specifically, move. You know, and operands. So these are operands are things. You got the number five. You know, this kind of syntax 5 to 2 or 42. There's an operand, something you're operating on, like the number 42. There's a operand, you know, and this bytecode generation. You can generate bytecode from the system. And the output here is in two ways. You can have a kind of a flag, detach flag. You know, these are really program. You can have a program exe or an exe program from the Rift system on output, tangible output from Rift. Well, 311 is stability here. So you got 311, meaning you get an output program. But you get 3110 or 3111 or 3111 minus 1. Okay, so I'm going to 3111 3111 so these are two success codes. Anything zero and above is a success. You know, this one just means this one just means valid bytecode. You go generate a valid bytecode. You know, bytecode is valid. Now it just means a program code is valid. You know, I'm thinking of ways to just make it more intuitive. But this is a program. You have a bytecode program. You know, program like exe or some program from the Rift system that you gotten, and that is the program you run. Yep. And we'll go to now for Rift 4. Rift 4 now is Rift 4. Rift 4 is the governance model. But you know, if you want to go to Rift 4 is about using that bytecode or program to in detach mode. But there's something called detach mode. So when you get Rift 3, you get something called detach mode. Detach mode works like this. You have to check in the config. Yes, I want to detach from the system. Detach mode gives you yes, detach. Detach mode can give you one program, one bytecode. Give you the bytecode or you detach what you generate of the program. But Rift will not. You'll not use the. You'll not use the. You'll not be able to. You have to govern it yourself. You have to add the configuration layer. So you have to. Whatever that artifact is creating, you're now developing the programming language system with its own schema. What it means to run this kind of program, you know, a gossip programming language, based on the standard spec, you know, it allows you to attach the system from that Rift system. When you use the Rift.exe, Rift.exe, that's detach. You have to have a valid configuration, like a configuration. Oh, sorry, this is not very coherent. Yep. So you have a when you run the detach mode. So when you do so when you have a gov the Rift dot n you know, this was 4 is the detach mode. Rift 3111. Let's say I have a bytecode 13110 here, and this is .xml. This one allows me, and I put that to ref.exe. Dash configuration. This file here, and I put dash detach. I get a prompt. Oh, this is bad. Detach. I get a prompt to detach. You know, but you know, this is detach or not, so I can put my own alphabet. You got to understand. Before you detach, and you're using Rift test, the Rift testing library, Rift test.exe. You got to understand one thing very important. Before you detach, you got to ensure that you have keyword using the keyword matrix, which is again true, positive, true positive, true negative, false positive, and false negative. So you gotta check all the checks first, not just two cases. False. This is false and it's positive. This is false and it's negative. And this is the negative just means failed. The test you wrote doesn't adhere to the positive. You basically add the wrong question. True, but it's negative. This is true. It's negative. So when you see negative, just mean you have to try a different question to see what that is. You got true positive, true positive, and we got false positive, false negative. Yep, and that's what that means. Yep. So that's what that is. But you have to do that, the testing first, and then you have to also ensure one more thing. Yes, the detach mode is like allows you to get your information system and do everything you want. Evolve the project your way, but when you detach, you can still go back. You can still go back. It's not just one way thing. If you're using some features of Rift, so the kind of way you detach is the kind of work way. So you got this kind of thing now. So you got the error system in Rift. Error system, if the error bug, the Rift will quit. Detach mode gives you freedom to not really care about what Rift errors are. The Rift error. So how does the system work? Is 0 to 3. So if you have 0 to 3, you are in the OK zone and you're able to detach. You're allowed. You're prompted not to detach. You're not given a second prompt. Okay, but it's a warning because the warnings are C warnings. And you got 3 to 6, which are the like this is a warning. Sorry, this is a warning. Get into danger. It's gonna become dangerous soon. Yep. This is okay to warning. Sorry. Okay to warning. Okay to warning. Okay to warning. And this is so this is the danger zone. So we're here. We in this detach mode. Detach is good here, but you cannot use the detach flag anywhere else. Here we have this is errors, error code, error, exceptions. If you get an error, an exception, or panic, you get these messages in your C code. Then you have to go back and fix that before you get detached from the system. And then we get 6 to 9. 6, 7, 8. So these are 1, 2, 3 errors. 1, 2, 3, 1, 2, 3. So go 1, 2, 3 tally. 6, 7, 8, 9. This is one in danger to critical. So that means you got a lot of errors, a lot of warnings, and you have to really try to mitigate them. And then you got the last one, 9 to 12. 9 to 12. Now 9 to 12 ones. This looks very good, but it doesn't look. This is very dangerous. I shouldn't do that. Oh shh. So 9 to 12 is really dangerous. That means the customer, because maybe it's a thread save issue. You have to panic. That means you have to quit. That means panic is triggered and you quit the system. And when you quit the system, Rift will say, okay, this is the maximum error I'll throw. The maximum I'll throw at you. It's always enabled unless you go alert, no panic. You don't want to do no panic flag. Unless you want to use legacy, you just want to see what is happening in your code. You can see the no panic. You can extend the error trace. But Rift normally just gives you caps it to 9 to 12 error. But you can extend this to 12 and beyond. 12 to 15, 12 to 16, etc. 12 to see what's actually happening in your program. Or to read the log files you can feed them to log files or any other output system, any other streams, like files, based on where you want to place them. Log files or error handling files. Okay, now I'll show you how this works in C. Yeah. So this is what I'm trying to do. So I've now gotten how that works. Let's see why this is different. So we got something called the R syntax. The R syntax is very important. I'll show you how this works now. So the R syntax is just this. Wait 1 second. So the R syntax is just this. You put it here. So this is the R syntax. So this is a C standard R. And we put One second. Okay, so this is the R syntax. This is called the R syntax. This is like a known as a rift regular expression. So this is known as a rift regular expression. See what I'm saying here is very important. So when you're in a C code base, you're really interacting with the rift regular expression, whether through macros or anything, to do some processing at rift core or rift stage 0 or rift stage 0. What this really is saying that say I want to match the word I want to tokenize the stream I want to tokenize the stream 00. I want to tokenize this to Lexeme. Let x take the value of 42. Let me just not actually. Let me just put answer. Let answer equal 42. You see, this means this is called the word sync. I want to tokenize this. I have to separate this into tokens. So this will match identifier. This will match identifier here. Identifier. This will match the type and value. The type and value of the answer without no explicit type setting. It's just no explicit type setting, but you know the type it is, because it's just equal to this one. Because this one declared the system, but it just means type and value. This one I want to declare. Say it's being my own language, and this is this is a keyword. This is a keyword. So this means something you can't use it. And this is a constant. This is just a number, 42. This is an integer, 42. But so that's what computer is doing. So to match this, you can use the R syntax to do it. So you can put it in here in expression and match it accordingly. So I was looking at expression before, but what does this mean? Yep. So this means I'm gonna write it again. Here I'm gonna write it again. I'm gonna write it R /A to Z 0 to 9 and backslash B. Yep, G and G by GB. So this means so you see we're gonna analyze this now. So this means R. So when you're in a C file and you do this syntax, you're really using the R syntax for your expression. You got the other variant, which is just a single quotes for single characters like S T B. Single Unicode characters. Backslash T, backslash B, backslash S, or backslash A. This is just what I mean. This is just single characters you can use, but you can't use it like this unless you're matching some kind of character set. And that's where that comes in. So this just means the first one means A is so this is a square bracket. This is called a character set. This bracket means character set. Character set. Gosh, this is not clear. So this means a character set. So I want you to character set. So this means yep. This means a character set. This means the start of a string. So this means start of a string. Start end string. Start end string. Or start end string to match. But it's not really a starting character. It's just a container. And this you got this one here. While in here, this one means not. Do not match or match nothing. Match not. Anything that so this will not match anything. And you got the syntax here, which is regular expression declaration. Declares regular expression. Just to contain that. You got that there, and we got this. So we got this here. Remember that. And we got the first of all, match anything. A to Z. So this is like a match anything that's not A to Z. So this is a character range. It's got the regular expression. So 0 to A to Z means 0 to A to Z. It could have been A to B, A to D. But it's a character range, etc. But this is A to Z. Match anything that's not A to Z. So this means not A to Z. A to Z. This is like and this is like a fine. And this we got this one here. And we got this one here. Match anything that's not 0 to 9. This means do not match anything that's not 0 to 9, or anything that's not a character basically. A character and a number. It's matching anything that's not that. And then we got the last one. This one. This means matching anything that's not a control B. This is not a. This is not matching anything that's not a boundary, like a space, a white space, or like a token, like a comma. So, anything that's not a white space, not a boundary, that's not a boundary. And this is just that's just rocket expression. This means global. Global. G for it means global option. Multi-line. M for multi-line. Multiple line. So we'll match multiple lines of the text until it's done. This means case insensitive. That means don't care about capital letter or big letter or small number. Just care about that. Don't care about that. And we got the TB, which I'll come back to later. But this means top-down parsing, top-down top-down tokenizer, which means top-down tokenizer means okay. Let's just do it now. So top-down tokenizer is a feature of the system. So if I use TB flags, I'm talking about this TB here. I'm referring to top-down parsing, or recursive descent, which is a top-down parser. If I use B, I'm talking about bottom-up parsing, or LALR platform. This is recursive descent, or RR parsing. This is bottom-up parsing. Bottom-up refers to the concept of like starting with the tokens and parsing, starting with tokens and parsing the system and parsing the code token. Yep. So this is the token. So the token types are like was the top-down parsing starts for the parser or the system to start parsing the semantic meaning, or the AST, or even a start. You can start from anywhere you want to start. But you got the two-time LR parser, which is bottom-down, which is faster for you start accumulating using something called breadth-first search. You search with the layer by layer. Starting at the tokenizer layer, or depth first search, going to the next, which is just starting from top down parsing, which is an RR parsing, recursive descent. RR, which is called the recursive descent, but it's just RR parsing. It's called RR or RD, I believe. But I don't know yes, it means recursive enumerable parser, which is top down. So that's the pathology support. And you can run this in parallel with the code TB. In parallel, when you run in parallel, you're really top-down parsing. This is why it's really fast. This is why it matters, because it doesn't really guess. You just do the same operation in concurrent way to solve a problem. And this is how we've changed the whole game. Using a simple thing. Now, see this rocket expression here. See this rocket expression. See this one here. Here. This is called, this is mapped to macro called Rift. Because it's nothing. Just because it's empty and this means empty automaton. Things a machine can do. So we can Rift. So we can make a macro for the state transition. So we go Rift empty Rift nil. Which means Rift nil or R nil. Or Rift nil, which is a macro, you can just plug into the sleep code to get that state, empty state, or Rift end of file. You declare that your parser is end of end state, and end of line, end of file. You don't want your parser to move forward. But these are state bound. These are techniques that are mapped to the macro system to perform some job of that system. Hence the Rift configuration. And now I'll show you next time. I'll show you the Rift artifact I made, explain to you how that works and how that ties in with the greater scope of things. Thank you for watching, and I'll speak to you later. Now you can go to github.com/obnexus/riftn, which is the old project, or github.com/ let me just write it down. Yep, you can go here and go to github.com/obnexus/MVP. and you should have a working copy of this stuff for minimal viable product of Rift. If you go to Rift, minimal viable product, you should hear minimal MVP, minimal MVP, OB Nexus. Yeah, you can get that Rift artifact settled. I'm gonna put this there too, so you can stand this, but it's very unclear to you. But you know, this Rift, we can go off to. You can just read the documentation to see what you get for Rift, Rift 6 and above. You can go to culture. Rift 5 is there, but this is a Rift 6. Yes, let me give you Rift 6 now. The low. Oh no, oh no. You know, this is just a Rift 6. Yep. So we got the Rift 6. Rift. So I know this is Rift file. Like, you know, this is Rift file. Let me just. I think I stopped at Rift 5. Yep. This is Rift 4 here. No, this is Rift 3. So this is the program. Oh yeah. No. I made a mistake. I want to put this bytecode here. I can detach a bytecode file, but you know, this the Rift 4 is the program stage. You know, taking the bytecode to an executable program. So Rift 4 is program. So you take the bytecode, you then do some program logic, which is main.exe, main.c. So you get the program, the executable, or the library, Sorry about this. You get the library, and that's Rift 4. You can detach a Rift 3 only, just to keep the system streamlined. But you make a library in Rift. Yes, it's a library, and you can get Rift 5, which is the Rift 5 is a culture one. So we have a library or program or some kind of data. You can then transform that to more tailored to a community. Like it's really design and technology here. You can design and technologize. You can design and technology appropriation. You can intersyllocum using firmware. If you remember GitRaf, so you can put this into hardware code, like, you know, silicon. We're using make it a functioning chip, computer chip with a GitRaf. You know, you can make it a CPU motherboard. GitRaf is a regulation of firmware solution to uploading code in silicon, and that's what this is. So this is an example of this. You can also extend regular expression, and when you do this, you can now have a hardware equivalent, of the software implementation, and that says Git Rift. So you got 5 and you got 6. So you got 5 here. 6 is culturally appropriate. So one more thing, you got 6 here. The 6th one is so you got the 6. 6 just means so you get that hardware program. You now tell it to other communities. Say it to Japan, Japanese accessibility layer. It's like a design and technical accessibility, or China, or America. You know, you make it feel that you make it transfer the accessibility features amongst cultures or communities or demographic. People can understand it in Chinese or read it in Korean, you know, based on what it is, or Igbo for that matter. And that's what stage 6 represents. It's a change of the silicon to adapt for the firmware. So this is firmware 5. This is 6 is hardware, silicon. Cultural. This is for cultural appropriate. The things that can integrate peoples. So if you're writing an app in C, I recommend you read the notation and understand Rift very well. On the next video, I'll show you example implementation of a system of a Rift in C. Okay, thank you. Goodbye. Bye. Take care. Add me, share, like, and subscribe, and go to github.com/obnexus MVP to try a Rift today. That's the MVP Rift.